You do want to have your graphing calculator out, like I asked you to bring, and you're probably going to just want to bring it every day. Okay. There's enough stuff going on in this particular section and sections moving forward. When we get into measures of central tendency, there's some calculations that we're going to use our graphing calculator for, because if we did it by hand, one, it's very confusing, and two, it would take a long time. Okay, and we have the technology to allow us to get to the information much more quickly. Now, those of you who don't have your graphing calculator with you today, I'm going to sort of record all the steps as we're working through this. You're probably going to want to write them down to review later when you go to do this on your own. But it is something that you need to know how to do on your quiz. It is something you're going to need to know how to do on your test. Okay? So, you guys know what a scatterplot is. You've made scatterplots. You've done them in science class. You did it in Algebra 2. You probably did it before then. Those for sure are ones that I know you've done. Okay, let's understand what it is. It's a graph of ordered pairs of data values that is used to determine if a relationship exists between the two variables. Okay, we're trying to see if when we put those points on a grid, if there is a trend, if there is some type of relationship between whatever the x and y are. And as a little review, x is the independent variable, y is the dependent variable, y depends on x. There are 4 types of possible relationships that we will talk about in here. Okay. And I'm going to show you each name, and then I'm going to give you an example of what it might look like per slide. Okay. And when we're talking about relationships, another word that you frequently hear when it comes to scatterplots is correlation. Is there a correlation between x and y? Okay? Or is there a correlation between the points that are on the scatter plot? So here's the first one. A positive linear correlation. Yep, you could take a picture of that. So if you notice, if I put a line on here, and just kind of a general line, it would look something like that, right? They form sort of a line. That's why it's linear. And it's positive because as I move from left to right, it goes up. The slope of that line is positive. Okay? The other way that we can describe the relationship and describe the correlation is whether or not it is strong or weak. And just for reference, I'm going to take that line out of there. Would we call this one a strong correlation or a weak one? Strong. Like the points are bunched pretty close together. They clearly seem to form a straight line. There aren't what's called outliers, points that aren't really connected. So another descriptor for this positive linear one in this case is that it is a strong positive linear relationship. Okay? Of course, we could have a negative linear relationship. Would we call this one strong or weak? What do you think? Strong or weak? Are the points bunched together in a way that it clearly defines the line? No. Yeah. I mean, you should see a line in there, right? Okay. Right? There's a line that splits it, and those points are all pretty tight to that line, so that's a pretty strong relationship there, okay? But it is negative because it goes down from left to right. The slope of that line is negative, so it has a negative linear relationship. I would call this one strong as well, okay? A couple more. Here's the next one. a nonlinear or curved relationship. Now, it seems like these points have a pattern to them. It just so happens that it's not a straight line. Okay? And if I tried to fit some type of line to it, it would look curvy, right? So that's what a non-linear or curved relationship looks like. So there's a relationship, it just doesn't happen to be a linear one. Okay. And remember, a scatter plot is being used to determine if there's a relationship between the x and y, and in this case there would be. Its equation just is not going to be a straight line. Strong or weak? I mean, you saw that line that I put up there, right? It literally hit every point. So, strong or weak? Strong. Okay. All right. The last one that we're going to look at. Anybody want to guess? What? No relationship. Just a bunch of points. There's nothing. I can't put a line to it. I can't put a curve to it. There's no relationship between that x and y. Like, they're so separate from each other. One's not causing the other one to do anything. Yeah. No. So that's its own separate category. So when we talk about strong or weak or linear or curved, okay, when we talk about those descriptors, we're saying that there is a relationship between x and y. There is a correlation between x and y. And then we describe its relationship. When there is no relationship, those descriptors do not apply. Now, there's an actual exact way to determine the strength or weakness of a relationship, a mathematical way to do that, and that's why I had you bring your calculators, because in order to do that, we need the graphing calculator to do it. It will do it for us, okay? Because as I said earlier, the calculations that are involved in order to do it by hand are extensive, and there's no reason to spend time doing that anymore because of the technology that we have. Okay. So let's talk about it a little bit. We have what's called a correlation coefficient, and everything from this point forward in the notes is not in your book. This is an add-in. Okay. We talk about it later on in the semester, but I think it's important while we're talking about scatter plots to hit on these things right now. The correlation coefficient is known as R. So this here, it's not like a missing word or something. It's the letter R. It's the correlation coefficient, and it's always going to be between -1 and 1 inclusively, which means it can equal -1 and it can equal 1. But that correlation coefficient is in between there inclusively. So you can't ever get an R that's bigger than 1. You can't ever get an R that's less than -1. It will always be in that range. Okay. Now, here's where the correlation coefficient tells us about strength. Okay. The closer that R value is to -1 or 1, the stronger the correlation between the x and y. So if you had a R that actually equals 1, that correlation between x and y is very, very strong in a positive way. So if R was 1, it's going to have a strong positive, in fact, it's going to have the strongest positive correlation, the strongest positive relationship that could exist. If it was -1, then it would have the strongest possible negative relationship. Okay? And your calculator, I'm going to show you where to find that R value in your calculator here in a little bit. Now, the opposite is true. The closer the values are to 0, the weaker the correlation is. There's still a correlation, there's still a relationship, it just is weaker. Notice I put round to 3 places. When we get to R and finding R and writing our equation, you're going to see a bunch of decimals. We want to just establish right now that for the line of best fit, for R, we're going to round everything to 3 places, 3 decimal places, okay? Assuming there are decimal places that keep going. Obviously, if it's a 0.5 exactly, we don't have to put the extra zeros on. Okay. So the next part that we do, this is all related to the line that fits that I was drawing on to those scatter plots before. That's called the line of regression, sometimes known as a regression line, sometimes known as a line of best fit. Okay. In Algebra 2, you probably hand drew a line of best fit to your scatter plot, and you made sure that it ran through a couple points so you could write an equation for it. And it was probably a good line. But there's actually one best fit line. Okay, and that's the line of regression. And that's why I say it's the best line of best fit. It most accurately describes the data in one equation, and we use it to make predictions. So oftentimes we're given a set of data, and then we're trying to use it to decide, okay, well, what's going to happen, I don't know, 5 years from now? And we have this line of regression that we can use to help predict what the values in that particular case might be in 5 years. This statistical analysis, this prediction stuff, is used in business everywhere. Okay? And businesses use this kind of stuff to make decisions on how they're going to move forward and how they're going to project where their money might be made, okay, or lost for that matter. All right, on the next screen, I'm going to give you the data that we're going to work with to find all of this stuff with your graphing calculator. Okay, so on the next screen, take a picture of the next screen because that's going to be the problem, and then we'll work through the mechanics of finding R and making a scatter plot and finding the line of regression. Okay, so here it is. Let's talk about what we're trying to figure out here first. Okay, the researchers are trying to make a determination if age impacts the number of accidents, the number of car accidents that occur, okay? And what we want to do is see how strong that relationship might be, okay? Now, this is right in your wheelhouse, right? Because you're all in this range. And of course, when you first got your license, I hope you were really careful driver and you paid attention, and then you got comfortable as a driver, right? And you probably check your phone once in a while when you're driving, hopefully not. Turn the music up a little more. You're allowed to have passengers in the car. Well, as you got more comfortable as a driver, the risks to everybody else seem to go up, according to this, right? Not a little bit, a lot. Okay?
Passengers, when you're 16, you can have passengers in the car.
Legislation that initially when you get your license, it's attempting to make it safer for everybody, not just you, okay? Everybody on the road. And as you get, as that legislation backs off because you have more experience as a driver, okay, drivers might become riskier drivers. And according to this data, maybe that supports it a little bit. But then it kind of levels out too. After you get out of high school, maybe you become more mature and responsible. I don't know. That's what they're trying to figure out. And the fact is, insurance companies use this kind of data all the time to determine how much insurance is going to cost, right? All right, so one of the things that you are going to be able to do from this point forward is use your graphing calculator to make scatter plots. Okay, this is a small data set. There's only 6 points, okay? and if we had more than 6, it would just take us too long. But let's talk through what you need to do in order to enter this into your calculator. Okay? And for those of you who have to go back and watch the video, this is just going to stay on the screen for a while. It's going to be me talking because it's recording, but there's nothing for me to do. Okay, I'm just going to explain what you need to do. So, what you need to do is go into your stats menu. Okay, I believe there's a stat button. It should be right under the delete button. Hit the stat button and you'll get a menu. I'm going to look over one of your shoulders while we do this. Okay? And the first menu item is edit. Go ahead and hit that. And you should get a table. Okay?
How do you hit it?
Hit enter. Okay? You should get a table. And there's a chance that you have data in there. Does anybody have data in their table already? Perfect. So that's easy. That makes it nice. Okay. So what you see on your columns, you have L1, L2, L3, etc. Okay. That means list 1, list 2. And those are the columns that we're going to use. We're going to have list 1 as X and list 2 as Y. So take the data that we have here and enter it into your table. List 1 is the X, list 2 is the Y. So now we want to look at the scatter plot. We're going to look at the scatter plot first. And where you want to go now is, so go to hit the stat plot button. That is above the Y equals on your calculator. So you got to hit the second key or whatever and then stat plot. Okay, and so what you should notice is that it says plot 1 on, plot 1 off. It should, first of all, we need to turn plot 1 on. Okay, so they all probably say plot 1 off. So scroll over to the off and hit enter, and it'll change for you.
Oh no.
Okay, and turn it on. So once you get into that plot,
What's this? What do I do? You can do types.
so notice in your stat plot or in your plot menu, when you go to turn the plot on, there are options. Okay, there's a little picture of a scatter plot. There's a little picture of a curve. There's a little picture of a bar graph. Okay, there's probably a picture of a line. There's all kinds of different things in there. Okay, your graphing calculator is very powerful. It can do a lot of the stuff for you once the data's in there. Okay, make sure that you turn the scatter plot 1 on. It should look like a picture of a scatter plot. Turn that one on, and then once you're there, make sure your X list is L1, and make sure your Y list is L2. Okay, in your if you notice above the numbers on your calculator, there's L1, L2, L3. So if you get to a point where you want to change the lists, and you want your graph to be of list 3 and list 4 at some point, if you wanted to do that, that's where you would change it. Under the stat plot menu, you would tell the calculator which list to actually pull your data from. Now, since you haven't done this before, it's already preset to be L1 and L2, and that's where we entered the data, so we're good. Okay? Now, hit the graph button. So, if you hit the graph button, you're like, but there's nothing there. Okay? Whoa. Okay, if you have a curve there, like that, then go to your Y equals screen because you have an equation already typed in there and you want to erase that. So if you go to the graph screen and there's some kind of crazy line or something on your graph, it's because you still have an equation in your Y equals screen that you need to get rid of. Okay? But here's why you don't see anything. The standard zoom menu is a 10 by 10. So negative 10 to the left, positive 10 to the right, positive 10 vertically, negative 10 horizontally. Well, our data starts at 16 for the X, and it starts at 5,974 for the Y. So it's not going to show up in the window that you're looking at. So we have to change the window. Okay? Now, you have some options in terms of changing the window. You can hit the window button and manually change the left X and the right X and the upper Y and the lower Y. And in this case, you might go from 15 to 25, for example. So you can manually change the window, okay? But there's another way with Scatterplots that you can actually zoom in on the data that you're looking at. So if you hit the zoom button, so the zoom button's across the top, and then scroll down, I believe it's number 9, it says zoom stat. It will zoom in on the points that you actually need to see. It'll automatically change the window so that you see the points that you're actually graphing. Zoom button, number 9, zoom stat, and there's your scatter plot. Okay? So for your homework, when you have to make a scatter plot, I'm telling you right now, I will allow you to use your graphing calculator. However, you're going to have to take a screenshot of your calculator and embed it in your homework. Okay? If you want to draw it by hand, you are welcome to do that. I'm just telling you this will save you some time. Okay? So that's the first thing, the scatter plot. Any questions? Other thing, Sophia was playing around with the little cursor and said, I don't think it's accurate. I got my cursor over my point and the digit's off a little bit. Well, because you're not actually on the point exactly. If you hit the trace button, it will literally drop on one of those points. And if you toggle around from point to point, it will be exactly the values that you entered into your calculator. Okay? Now, the next thing that we have to do is we have to allow our calculator to find our correlation coefficient and draw in the line of best fit, okay, the regression line. Now, what type of relationship is there? I mean, you can tell by looking at the points. There's a negative relationship. So we should see that our R value is negative. We should also see that the slope of the line of regression will be negative as well, okay? Because that line of regression is going to be going down from left to right. So your next move in order to do that is go back to the stat menu. So hit the stat button again, and then slide over to the calculate, okay? And then you see number 8 says linear reg, linreg, that means linear regression. And notice that it says, before you hit enter, don't hit enter yet. Notice that in parentheses it says A plus BX. That's kind of slope-intercept form, right?
Yeah.
A is the y-intercept in this case, B is the slope. So when you hit enter, the screen is going to give you a bunch of data. So hit enter. Oh, sorry. It's going to make sure that you're pulling from the right lists. So it says X list L1, Y list L2. If you don't have that, so the next thing you have to do, so depending on which calculator you have, when it comes up on the older ones, it'll say linreg, and then it'll say parenthesis A plus BX and parenthesis. Now you have to put the lists in. You got to tell it what list to pull from. So hit L1, that's above the number 1. And then comma. And then hit the comma, which is under the sign button, and then put L2 there. You don't have to do it. You guys with the TI-84 plus CEs, you won't have to do that, okay? But at that point, for you guys with the newer calculators, you can just scroll down to calculate and hit enter. Those of you with the older ones, that after you've put the list in, you can hit enter and it'll do the work for you.
Now can I press enter?
No, now hit enter.
So it's B.
Okay.
Huh?
So now what it gave you the A and the B. So remember the form that it was in, A plus BX. So my equation, now hit the Y equals screen. Okay. Here's what I want you to do. So for this one, okay, when you get the screen that says what A equals and what B equals, write that down to 3 places. Write A down, A equals whatever to 3 places, B equals whatever to 3 places. Okay, so hold on a sec, because what was supposed to come up on that screen was also the R value, and it didn't for most of you because your calculator's not set up to do that, so we have to set it up to do that. Okay, we should have done that first, and that's my oversight. So what we have to do is hit the catalog button. So the catalog button is above the 0. Okay, and then what it probably says right now, oh, go down, keep going down. Keep going, keep going, keep going.
We'll go to L2.
Go to diagnostic. There's supposed to be a diagnostic on there.
There's so many things.
I know there's so many things.
Diagnostic. It's in alphabetical.
Okay, so go to diagnostic on and hit enter. Okay, you have to turn the diagnostic on. Now go back to the linear regression and it should work for you now.
I don't think it did.
Keep going, you gotta hit calculate.
Mine didn't work.
Yeah, it worked.
Okay, so once you turn the diagnostic on, not only will they give you the A and the B, but it'll also give you the R. So go to catalog, which is above the 0.
Can we press second zero?
Yes, second 0 to get to the catalog. Hey, quiet down please, quiet down so we can hear the instructions. Go to catalog, scroll down and turn diagnostic on. Okay, so you actually have to click enter for diagnostic on. And then once you do that, go back to the linear regression, so it's in the stat menu, calculate, make sure your lists are right, hit enter, and now instead of giving you just the A and the B, it will give you R squared, and it will give you R. R squared is the correlation coefficient squared. But what we need R, and we need the A and the B. So here we're going to put the linear regression line on our scatter plot so you can see what it looks like. Okay, for now this is what we're going to do. And if I figure out the way later, I'll show you. But you have A and B written down. So what I want you to do is I want you to go to your y equals screen. Okay? And you're going to type the equation in for the line of regression, rounding it to 3 points. So the equation is y equals A plus bx. So what you have to do is enter in your A, enter in your B, and then put an X next to it. Okay? That's on your y equals screen. We're entering the equation in. Yes, on the y equals screen under y1, you're going to enter A in and B times X. So then after you enter that in and hit graph, it will put that line of best fit on your graph with the scatter plot. Okay?
I don't know. I guess.
Okay, now here's the thing I want you to do. Okay? Anybody have an issue? We got it figured out. Anybody still having issues? Yes.
I was only going to be using our calculators. Mine's almost dead.
No, mine's not even there.
Okay. Here's what I want us to do. Okay? You enter this in the y equals screen. So you hit the y equals button and then you enter your A plus bx. Here's what I want you to do. We're going to clear the whole thing out and do it again. For practice. No, for practice. I want practice. The X button, it says X, T, theta. It's right next to the blue or green button. Yeah, yeah. Yeah.